Okay, we will continue from where we had left in the previous class. We are looking into the construction of stator, and we saw different winding details and then insulation details in the induction motor. You can see these are some of the photographs wherein the insulation details are given. See, for example, first figure, top left one. See, in the slots, the slot liners are placed. Slot liners are placed, and then winding is placed in one of the coil. One coil is placed, or rather, two coils are placed here. Okay, and then the right top one. See, more number of coils are placed in small induction motors. The wires used are thin, round wires, and hence coils will be small like this. They are also farmer owned, but they are small coils and there is no proper fixed shape for them. As I told in the previous class, for large machines it will be diamond shaped that you have seen. Now there is no fixed shape here. Okay, approximately it is oval shaped. Oval shaped. Some more windings are placed here in the third figure, that is bottom left, and then bottom right. All the windings are placed, and then you can see the binding of the overhang is also done. Binding of the overhang is also done. So that's about the stator winding details, some figures. The slot details also we saw. Here you can see these are the coils which are diamond shaped. They are in case of big induction motors. In case of small induction motors, the coils are oval shaped and the conductors used are circular thin conductors. Okay. We also saw the insulation details of the slots to get you an idea how it is done. Then let us go into the details of the rotor. Rotor is the rotating part of the induction motor. All the parts in the rotor are rotating. All the parts in the rotor are rotating. Hence, it is called rotational part or rotor. There are two types of rotors by construction. By construction, one is squirrel cage and other is called slip ring or wound rotor. Squirrel cage, slip and slip ring. Generally, squirrel cage and slip ring. Sometimes slip ring induction is also called wound rotor. Okay. So let us go into the brief details of construction of these rotors. Squirrel cage rotor is called so because once the rotor is completely finished, it looks like the cage of a squirrel. Cage of the squirrel. That's why it is called squirrel cage. The rotors are also made up of silicon steel laminations put together to make the rotor core. Rotor core. Okay. The rotor slots may be open or semi-closed or even closed. Open rotor slots are in case of large machines. Semi-closed slots are in medium machines, and closed slots are very small machines. Closed slots are in very small machines. Okay. To give an idea, see in this figure, left bottom is the rotor. This is the rotor of the same stator. Okay, rotor. Here you can see that the laminations are put together to form the rotor, and the rotor is having closed slots. See here, this is the squirrel cage rotor. These are all rivet holes, or maybe sometimes ventilating ducts also. Okay, this is the central hole for the shaft. Okay, this is the rotor core. You can clearly see these are all closed slots. Sometimes in little larger or medium machines, the rotor is semi-closed. In large machines, it is open. Okay. In those rotor slots in squirrel cage induction motor, what is done? Copper bars are placed. Copper bars of different size and shape. Maybe circular bars or rods or rectangular rods, sometimes square rods, depending upon the type of the slot being used. Rods are placed. Okay. So in each slot, there will be one copper bar, generally copper bar. Okay. Uh, Actually, in this open or semi-closed or closed slots, most of the times it is semi-closed or closed slots in squirrel cage induction motors. What they do is they will hammer these copper bars into these slots. Copper bars or copper rods are hammered from one side to the other side. Okay, and then for your information, these copper bars which are around the rotor slots or rotor are short circuited by end rings. They are short circuited by end rings. On the two ends, there will be copper rods coming out of the slots. You imagine, I will show you some photographs later. From the two ends of the rotor, there will be copper bars coming out of the slots. And all these copper bars are short circuited ring on these copper bars, circular ring in a on the copper bars, and they weld these copper bars to the ring on both the sides. These rings, which are put on the two ends of the rotor to short circuit the rotor bars, are called end rings. End rings. Okay. Because the copper bars are placed, the cross section of the bars is quite high, and hence the rotor resistance will be quite small. See, in the rotor slots, there is one copper bar in one rotor slot. Either they are circular or rectangular in size, so cross-sectional area will be high. Rho L by A is large, so resistance will be very small. And all over they are short-circuited. Hence, the resistance of the rotor is small. Therefore, what happens is that such squirrel cage rotors will have poor starting torque. Okay, you can see that the starting torque is proportional to or inversely proportional to the rotor resistance. Smaller the proportional to the rotor resistance. The starting torque is proportional to rotor resistance. Smaller the resistance, smaller will be the starting torque, or higher the resistance, higher will be the starting torque. So, see, this is a limitation. Here itself, you should observe. This is a limitation. The starting torque of a squirrel cage induction motor is very poor. Hence, these squirrel cage induction motors cannot be used in the case where you need a high starting torque. You need a high starting torque. Okay, that's why what is done. There are two other types of squirrel cage induction motors, which are called double cage or deep bar rotors. Please note, there is no difference between the stator of a squirrel cage rotor or stator of a squirrel cage motor or slip ring motor. Whether it is slip ring induction motor or squirrel cage induction motor, stator is similar. In both the case, stator is 100% similar. Difference is only in rotor construction. Hence, the name squirrel cage or slip ring. Okay. So to improve the starting torque in case of squirrel cage induction motor, there are another two rotors called double cage and deep bar rotors. I will give you more details regarding this double cage and deep bar rotors later. Okay. Next one is slip ring rotor. In slip ring rotor or wound rotor, the windings are placed instead of copper bars, similar to stator. See, in stator you have seen windings, three-phase windings. If it is the case of three-phase induction motor, there will be three-phase windings. These windings, which are here, belong to three different places, R, Y, B, or phase A, B, C. Okay, phase 1, phase 2, phase 3, phase R, phase Y, phase B, R, Y, B. Okay, three phases. Similar to this type of winding, in wound rotor also there will be windings placed, whereas in case of rotor, squirrel cage rotor, only bars are placed. So three-phase distributed winding in semi-closed slots. Okay, semi-closed or open slots, three-phase distributed winding will be placed. You know, when it is three-phase windings, there is each phase will have one coil. That means two ends for each phase. Two ends will be there. They have to be properly connected. Properly connected means three-phase winding, similar to transformers. Either they have to be connected in star or delta. So what is to be done? See, these for that, what is done? The ends of these ends of the windings are connected to slip rings in one side. At one end, they are connected to slip rings. Okay. Other end, usually connected in star. Okay. So what are the slip rings? The slip rings, I will show you the photographs. The slip rings are made up of brass or phosphor bronze. Brass or phosphor bronze. The advantage in this type of rotor, slip ring rotors or wound rotor, is that, see, there are 6 ends for each phase. 3 ends are connected together to form the star. Other 3 ends are connected to slip rings. Through other ends, that is through slip rings, you can insert the rotor circuit, resistance in the rotor circuit. You can connect resistance to the slip rings. Star connected resistance you can connect to the slip rings, and hence you can increase the starting torque. Please note, these resistances are called starting resistances, and these resistances will be in the circuit only during starting. Only during starting. Okay, let us go into the more details of construction. You see, you have seen this one as the stator lamination. Inner one is the rotor lamination. Are you able to see? Hello? Hello?
Yes, sir.
See, carefully observe.
Yes, sir.
The stator lamination is having the slots from the inner periphery, this one, whereas rotor lamination is having slots from the outer periphery. Okay, slots are on the outer periphery. This ring is rotor ring, rotor lamination. Here you can see, this is the photograph of a squirrel cage induction motor. See, here you can see white line like. They are the bars placed in the rotor laminations. This is the end ring. You can see at the end 2 rings, one here placed. They are called the end rings. These copper or aluminum bars. See, in case of small rotors, even aluminum bars are used. In case of very small machines, the